Hi everyone, welcome to this presentation. My name is Hoping and I'm from the second Lady Hospital of Nanjing University, China. And my presentation title is Deep Learning Assessed Identification and Quantification of Aneurysm SH in Non-Contrast CT scans and development and external validation of hybrid 2D and 3D unit. Firstly, let me briefly introduce my institutions. The California Hospital, Nanjing University. It was founded in 1927 and it is now have 57 clinical and medical technology departments. Um, Up to now, in our hospital, the number of intracranial aneurysm surgery is about 1,000 per year, and rupture aneurysm accounts for 15%. So let me see the detailed intracranial aneurysm summarize. The total number of intracranial aneurysm from 2020 to 2020 years, it reached a very high number of aneurysms. As you can see, the ruptured aneurysm surgery is reached a very higher number of patients. Today, the presentation is divided into 7 parts. First, let me see the introduction. As we know, the reading of aneurysmal SH often precludes satisfactory functional outcomes, and non-enhanced HIT CT scans can underwin the severity of SH stroke. Accurate identification and quantification of aneurysmal SH are critical for stroke assessment and improving morbidity and mortality outcomes. But we know manual or semi-automatical segmentation in NCCT imaging could lead to inevitable subject error and limited generations. So, with artificial intelligence in medicine, the AI is a significant promise technology that can efficiently and precisely process medical images. Mm, in the in our previous work, we have done the literature systematic review. That is results show that several creative work on NCCT imaging segmentation based on hybrid models, but some models only use 2D or 3D for encoding, and then 2D or 3D models for decoding. And both of those models use independent 2D and 3D coding and decoding model to fetch radio orange features such as Chang and his colleagues do their work. And we can we also can say the distribution of aneurysmal SH in ACCT is uneven, and its shape is extremely irregular. So we wanted to say the creating methods cannot identify and classify the hemorrhage features well. So under the introduction and backgrounds, we make an innovative hybrid network to segment hemorrhage. As you can see, the left figure, it is the flowchart of our models development and test and validation process. As this flowchart is animated, we construct the hemorrhage AI software and how you can use the software to process medical images of SAH. And the red figure, as you can see, the network of hybrid methods. It's it means this figure means that I'm different from create methods that use any 2D or 3D decoding methods. And our methods used hybrid 2D and 3D model to um, to decoding, and it will accurately identify and quantify the hemorrhage on NCCD images. That's all. Also, we can see the network can enhance results of identification and quantification of the ASH radiologic features. This table illustrates the baseline characteristic of patients in the internal and external datasets. As you can see, the marked CT scanner type. We use 3 CT scanner types to train our network. That includes Siemens, Philips, and GE Medical Systems. And these bleeding types that is shown SH within vascular hemorrhage is the common type after aneurysmal SH. And in dataset A to dataset D, the preparation of SH with in vascular hemorrhage is fetched very high preparation. The average is reached 15% or SH images. And we illustrate the datasets from different institutions from 4 provinces in China. And CCA means Nanjing University, and dataset B means Wuhan University. Dataset C means Army Medical University affiliated Xinan Hospital, and dataset D means Zhejiang University affiliated First Hospital. This page shows the performance of hemorrhage identification using hybrid 2D and 3D UNet algorithms. As you can see, the accuracy of identifications is reached very high performance. That is accuracy value is reached 99%. This page shows that the performance of hemorrhage layer segmentation in the internal and external datasets. As we mark the dataset, you can see in dataset A, SH and in intraparenchyma hemorrhage and in ventricular hemorrhage reached super well segmentation performance with death coefficient is 75 to 89%. And this mark we use dataset D to independently in validation and test our model. That the death coefficient is reached very high performance. That is value is reached from 71% to 89%. So we also illustrate some cases of identification and classification and quantification by our hybrid methods. The left figure is demonstrate the common location of SAH identification by hybrid 2D and 3D UNet. As you can see, this is that the label by our neurosurgeon or radiologists, and the media for algorithms performance is that to compression of the label and our methods. So from the eyes that you can observe, our algorithms reached a very high consistence with the label by neurosurgeon. As a middle figure that shown is the uh, bleeding types of the aneurysmal SH. From top to 10, bottom is SH in punctular hemorrhage, in vascular hemorrhage, and other compilation types. As the right illustrate is the hemorrhage types dropped by aneurysmal SH. We also make a consistent comparison between hyper-2D 3D UNet automation and neurosurgery manual segmentation. As you can see, the SAH consistent performance is reached 81.5% to 95.7%, and the or hemorrhage segmentation is reached 92.2 to 98.5%. In the final, we also make available tool for your clinicians that is software named Brahoma AI tool. As you can see in the interface that you can upload your datasets and it will automatically process your data, and then the results will be illustrated in right here. So make a discussing, we think our software can accurately identify, segment, and quantify bleeding after aneurysmal SH, but this limited on training setting scans on admission. Second, I think it does not train with the longitudinal data of aneurysmal SH, so it is limited to use the software to evaluate the hemorrhagic clearance after surgery intervention. And the third point is that the platform is interoperable, working well with different CT imaging formats such as LEAD, DICOM formats. Further investigation of the bleeding volume in association with complications, disability, and death in patients with aneurysmal SH should be done in the future, and I think this software can aid clinicians to better evidence effectiveness of SH clearance. Let me see some cases by the Brahoma software developed by hybrid 2D and 3D algorithms. And so this first step is that you should upload your datasets with SH. So the case is that SH any in NCCT scans. So we clinic started to automatically process medical images. So right here we can see the red mapping. That means the software has acquired the full brain mapping, so you can clinical continue. Yes, it's great. As you can see right here, the results of identification and quantification of hemorrhage is reached. And the SAH quantification is about 44 militaries. Okay, next. Um, Next cases that illustrate the SH with in punctular hemorrhage. As you can see, the right figure is the original image date, and the left figure is the illustration by Brinholmeyer platform. That you can see the SH combination with in punctular hemorrhage is well identified and classified by this tool. Okay, this is the same type of SH quantification and segmentation. Okay, that's where I wanted to share in my presentation. Thank you very much.